Good morning. My name is Davide Martinenghi, and I am presenting joint work with Paolo Ciaccia and Riccardo Torlone on preference queries over taxonomic domains. The goal of this work is to lay the foundations for finding the best objects in a dataset according to given preferences. The context we have in mind considers values from taxonomic domains and preferences that may contradict one another. Preferences may be specified over values that are more generic than those in the dataset and may thus need to be propagated down to the objects of interest. This requires a model for data, taxonomies, and preferences based on which we can establish the main desired properties of preferences, namely transitivity and conflict resolution. This setting may lead to intricacies even in simple cases, as I will show with this example regarding preferences on Italian wines. We have a data set listing wines and corresponding wineries and production years. And we have a set of preferences. For instance, we prefer white wines to red wines. We prefer a specific red wine, Amarone, to all white wines. We prefer wines from the province of Siena to those from the province of Asti. And in the wine region called Langhe, we prefer aged wines to young wines. We may need taxonomic knowledge to fully grasp the meaning of preferences and data. For example, to map wines to wine colors, or wineries to wine regions, or production year to wine age. A conflict emerges from the first two preferences, since Amarone is a red wine preferred to white wines, although we generally prefer white wines. Also, if we transitively combine preferences, we may obtain new preferences. Here, since Asti and Langhe are overlapping regions, we derive a preference for wines from Siena to young wines from Langhe. Observe that these new preferences may in turn be in conflict with other original or transitively derived preferences. The model we adopt is simple. A taxonomy is just a partial order on values which are used in the dataset and in the preferences. Preferences between specific tuples are represented in a relation. For stating such preferences, we use simple logical statements referring to attributes and values. When no ambiguity arises, we can omit attributes and variables, thus obtaining a simpler notation. We adopt two operators to rewrite preference statements so as to enforce the desired properties of preferences. Operator T enforces transitivity, so that from the previously declared statements we can conclude, for instance, that wines from Siena are better than young wines from Langhe. The S operator is based on a notion of specificity used in non-monotonic logic, according to which more specific preference statements take precedence over more generic ones. This operator can then be used to solve conflicts between preferences so that we can conclude that white wines are better than red wines, except for Amarone. The main research question we tackle is whether we can apply these operators in any order and possibly with repetitions to obtain a formula that amounts to a transitive preference relation without incurring any conflicts. Surprisingly, out of the infinitely many possible sequences containing both operators, there are only 8 distinct non-equivalent sequences, and none of them satisfies both transitivity and absence of conflicts at the same time. Notice that transitivity guarantees that results are never empty and always stable. That is, a tuple is better than another tuple regardless of the presence of other tuples in the data set. Both guarantees are lost if transitivity is not enforced. Since transitivity cannot be waived, the best we can hope for is to minimize conflicts while keeping transitivity. 2 minimal transitive sequences exist, which are incomparable and thus capture 2 alternative semantics for preference queries. We also observe that the mutual exclusion between transitivity and conflict resolution is unavoidable, and that no method whatsoever, not just those based on the T and S operators, could solve it. After testing our framework in a number of synthetic as well as real scenarios, we conclude that formula rewriting for the chosen sequences incurs a low overhead. Such sequences are also effective in reducing the cardinality of the set of best objects and in achieving substantial speedup with respect to baselines. That is, no rewriting, indicated here as epsilon, or just enforcing transitivity, indicated here as T. The speedup is further incremented when adopting a heuristics exploiting the idea that lower levels in the taxonomy are associated with fewer tuples, so that a smaller result can be found without scanning large amounts of data. In our approach to finding the best objects with respect to given preferences over taxonomic values, we have devised a model for representing data and preferences over taxonomic values, and have considered 2 operators for enforcing the main desiderata of preferences, namely transitivity and conflict resolution. After discovering that they cannot both always hold at the same time, we have found 2 sequences that minimize conflicts while guaranteeing transitivity and have tested their effectiveness experimentally. Thank you for listening.